Okay, CP Chemistry. We're back to the old mole to gram business. And I had got a couple emails saying that you had some trouble with the worksheet. That was the worksheet that was called the mole worksheet. And I think we got it. I think I gave it to you Monday, and you'll be looking at this Wednesday. I know it's a short period for you today. So instead of starting some brand new material, I just want to go through and show you how to work through, oh, at least the first 10 of these problems, if not more. We'll see how the time is looking on the recording. But I told you on Monday that we have to understand this idea of moles because that's how chemicals combine as particles. Uh, uh, you don't say, I'm going to take 3 grams of sodium and mix it with 3 grams of chlorine and get sodium chloride. No, I take 3 moles of sodium and 3 moles of uh, chloride ions and I mix them together. Well, it's very simplistic, but I think you get the idea. These things react in numbers rather than by mass. But we have to be able to count them out by mass, and that's where this mole to gram business comes into play. So let's take a look at this worksheet again. Let me get rid of this stuff here and see if we can at least work through some of these. I'll try to make this about a 10-minute video or so, and if you haven't finished the book assignment or the worksheet assignment, then please take the rest of the time to do that, and I will see you tomorrow after I'm done with my COVID confinement. So, first question says, now this is the worksheet, and the first one says I have acetic acid CH3COOH. That's the chemical formula. I could also write it like this: C2H4O2. These two things mean the same. And it says how many moles of acetic acid are contained within 24.71 grams. 24.71 grams of acetic acid, CH3COOH. Now, what we have to do is we have to figure out how many grams are in 1 mole. So I do that by saying, okay, I've got 2 carbons, and each one has a mass of 12.01. I've got, 4 hydrogens, and each one of those is going to be 1.08 or 008 rather grams per mole. And then I've got 2 oxygens, and they're each 16 grams per mole. So if I add that up, let's get the old calculator going here. Well, you don't really need a calculator for that. You've got 24.02. Well, let me see here. I don't want to mess it up here. So we've got 2 times 12.01. Oh, see if I can go back here. And I'm going to add to that 4 times 1.008. And then I add to that 32. And that gives me 60.052 grams per mole. So 1 mole of CH3COOH is, what did I say it was? Where did my calculator go? Come on back, calculator. 60.052 grams. And so now what I do is I just divide and see what I get. So I'll go back to the calculator. So I'm going to go 24.71 divided by 60.052, and I get the answer 0.4114 moles of CH3COOH. And that's the way you would report the answer. You'd have the unit of mole, and you also have the chemical compound to which it refers. All right. I have 57.3 grams of sodium carbonate, Na2CO3. That's why it's important to know how to write the name from the formula. And I want to figure out how many moles that works out to be. Well, all right, let's get the calculator going here. Probably a lot easier if I just use my handheld calculator, but I don't know where it is right off the top of my head. So we'll clear that, and we'll say molar mass of sodium carbonate. I have two sodiums, so 2 times 22.99, and I'm going to add to that a carbon, 12.01, and I'm going to add to that 3 oxygens, 3 times 16. So the molar mass is 105.99 grams. 105.99 grams per every 1 mole of sodium carbonate. So back to the calculator. 57.3 divided by 105 point, oops, 0.99, and I get 0.541. I'm going to round that. 0.541 moles of Na2CO3. So they're not that bad to do. Let's go through a couple more here. Maybe we can get through like the first 10 of them, and that way you can go ahead and do the rest of them. So, alrighty, let's see if I can just erase everything. I guess it's not going to let me erase everything. I'll just do that. I'll just flip up. All right. How many moles of sulfuric acid in 157 grams? Question 3. 157 grams of H2SO4. And let's see here. We don't need to bring the calculator up. Hydrogen, I've got 2 times, let's call it 1.0. Rounded to the hundreds place. 1.01. I've got a sulfur, only one of those. And sulfur is 32.06. 32.06. And, oh, I forgot about my oxygens. I've got 4 times 16. Which is 64. So I'm going to have, let me see here, that's going to be 2.02 plus 32.00 plus 64. 208.9, 98.02 grams per mole. 98.02 grams per every 1 mole of H2SO4. So I go ahead and I divide that. Looks like it's going to be about 1.5. So where's my calculator? So let's say okay. 157 divided by 98.02. I get 1.60 moles of H2SO4. So I went from grams in this case to moles. Okay. Number 4. How many grams of sodium hydroxide are in 0.785 moles? So I have 0.785 moles of sodium hydroxide. And now I want to get to grams. So I need the grams on top and the 1 mole on bottom. So sodium hydroxide, let's see, that's sodium's, I'm just doing these numbers off the top of my head. I don't have a periodic table in front of me. Sodium is 22.99. Let's just call it 23. Oxygen is 16 grams per mole. And hydrogen, let's just call it 1 for the sake of this calculation. So I've got 40 grams in every 1 mole. Now, when you're doing these things, I'm just doing these, because I know the masses of these elements. Now, when you do it, I'd like you to keep all of your masses to the hundredths place, okay? So when we multiply through, my moles are going to cancel. I'll be left with grams. It's going to be, what about 32 grams roughly? Let's see. Let's do the calculator here. A little bit less than 32 grams. So we're going to do 0.785 times 40 and 31.4 grams of NaOH. Okay, and that makes sense. 40 grams per mole. I have a little bit less than 1 mole. The way I did these things in my head, when I look at this, I say 0.785 is almost zero point 0.8, and 0.8, 8 times 4 is 32, so it's roughly about 32 grams. But use a calculator, obviously. If you can't estimate in your head, that's fine. I get it. I still can't figure this stinking program out. I'm telling you. Yeah, well, we'll just keep pushing it away here. Okay, so that was the sodium hydroxide one. How many grams of C6H6, how many grams are there in 12.7 moles? I have 12.7 moles of C6H6. So the molar mass of that is going to be, well, I've got 6 carbons. Each one's about 12 grams per mole. So that's 72 plus, because I've got 72 from the 6 times 12. And then each hydrogen is roughly 1, so about 6. So that's about 78 grams per mole. And you always want to label it. And when we do that, okay, let me get my calculator here. 12.7, 12.7, I don't know, it's going to be close to around 1,000 times 78, 990.6. So back and forth. The first thing you do, you look at your chemical compound. So let's take a look at the next one, CCl4. I've got 1 carbon, it's about 12 grams, and I've got 4 chlorines. They're about 35 grams apiece. And again, if you have a periodic table, go ahead and carry that out. 35, 35, 70, 140 plus, times plus 12. So 182 grams per mole, because I've got only 1 carbon. And so the question asks us, I'm looking at the sheet here, I've got 2.67 moles of CCl4 times 182 grams per every 1 mole of CCl4. And that's roughly, it's going to be probably close to about 420 grams. I don't know. Let me see here. 2.67 times 182, 486 grams. CCl4. So hopefully you can see these aren't bad. Again, I don't want to drag this on forever. You have a short period, and I want to give you time to work because tomorrow I'm coming back. Let's do one where we have to look at atoms, the number of atoms in a certain chemical compound. For that, if we're going from grams to moles, well, that's easy enough to do. We just have to divide by the molar mass. But then when we go from moles to molecules, we have to multiply by Avogadro's number. That's that big number, 6.02 times 10 to the 23rd. And so we're going to need that. And then if we go from molecules to atoms, we have to multiply by number of atoms in the formula. So let's take a look at an example. It says, well, let's go ahead and do 7 and 8, and then I'll wrap it up because the rest of them are all kind of the same, and I have faith that you can do them. If not, I'll be back tomorrow to help you. It says, how many molecules of ethine, C2H2, C2H2, that's an interesting chemical compound. It has a carbon-carbon triple bond and some hydrogens on the end. It's very flammable, and they used to use that actually in coal mines, in the miners' lanterns on their helmets. But anyway, it says I have 84.3 grams of C2H2, and I want to eventually figure out how many molecules of ethine do I have. Well, I have to get the molar mass of that. I know that 1 mole, well, I've got 2 carbons, so that's 2 times 12, that's 24. And I've got 2 hydrogens, 2 times 1, that's 2, so 26 grams. I always label it. And now I want to go to molecules, so I have to say, well, there are 6.02 times 10 to the 23rd molecules per mole. And so when I do that, it's going to be a pretty big number. I'll bring the calculator out for that, show you how to put it in the calculator. So we got 84.3. That's the number of grams I have of that material. I'm going to divide it by the molar mass. Okay, so that gives me 3.242 moles. So now I need to multiply that by, I'm going to go 6.02, and then I have a second, and then the E button. That's 6.0 times 10 to the 23rd. And my answer is 1.95 times 10 to the 24th. Molecules of C2H2. Okay, so that's a pretty big number, 1.95 times 10 to the 24th. So the next question says, how many carbon atoms are there? Well, I know, let me come down here and redo it. 1.95 times 10 to the 24th molecules, C2H2. And I'm going to say I've got 2 carbon atoms. I can spell it. Per molecule. My molecules will cancel, and I'll be left with carbon atoms. So 1.95 times 2, that's almost 3.90, right? Yep. So it's going to be 3.9 times 10 to the 24th. You don't need a calculator for that. Just 2 times 1.95, you get 3.9. And you carry over your exponent, or your times 10 to the 24th. And that would be carbon atoms. And that should make sense because I've got 2 carbon atoms for every molecule. It'd be like if I had 25 bicycles, how many tires would I have? Well, I've had 50 tires because I have 2 tires per bicycle. So that's how you do these problems. They're not difficult. And I'm going to give you the rest of the time to work on the problems in the book that I gave you on, I forget the page number, well, 100 maybe, or something like that, and then the worksheet. And tomorrow we'll have some fun working through these. So guys, take care. I'm looking forward to getting back in the trenches.